Oh, all right, Mitchell. You got me. I'm making another video. So, all of you can thank him for the fact that I'm making another one right now. He's my manager, so he knows what's best. And what's best is Mr. Wickens, Little Wickens, making another video. So, I'm going to talk a little bit about volume. I'll make a video on a cylinder's volume tomorrow or another day. But for now, let's look at just finding the volume of the rectangular prism and the triangular prism. The volume of the cylinder is very similar, but in the interest of making this video shorter than usual, I'll just go over these ones and make a video for the cylinder separately. So for prisms, again, the volume is just going to be, you can think of it as the volume of that front shape and then multiplied by the length or multiplied by the height if you're finding the volume, if you're finding the area of the top and the bottom. You're going to multiply it by the height or the length if you're finding the area of the front and the back. So here, with this rectangular prism, we have the front being here, and that is 2 by 4. The dimensions for that front piece is 2 centimeters by 4 centimeters. So the area is going to be 2 times 4. 2 centimeters times 4 centimeters. That's going to be 8. Now keep in mind it's centimeters squared. Those are the units, squared units. And I'm going to multiply that area of the front face by the length of that rectangular prism. So that means that the volume here, hopefully you can see here, the volume is going to be the area of that front face, the area of the front. I'll use that, this notation of the smaller letter underneath area to mean the area of the front, multiplied by the length, L for length. So that's going to be 8 centimeters squared multiplied by 3 centimeters here. So that's going to give me 8 times 3, which is 24 centimeters cubed. Those are going to be the units for volume. Now, notice that this is the same as just, this calculation here is the same as just the length times the width times the height. Because I am multiplying here, the width times the length times the height, depends on how you call it. Here I have the length multiplied by 8, but 8 is just that width and height. So I'm still multiplying the length, the width, and the height all together. So I could have done 2 times 3 times 4 to get 24 as well. For the volume of that triangular prism, we're going to have, again, the volume being the area of the front face multiplied by that length. So the area of that front piece, that front triangle, maybe I can draw that better. The area of that front triangle is going to be 1/2 times base times height, or base height over 2, in other words. And because the base is 4 centimeters and the height is 2 centimeters. Now maybe my picture isn't very accurate. I could have drawn it better. But if we assume that this is the picture, our area will be base, which is 4 centimeters, multiplied by height, which is 2 centimeters, divided by 2. We can actually see nicely that the 2 and the 2 divide to just leave us with 4, but keep in mind that we still have centimeters times centimeters, so that's centimeters squared. That leaves us with the volume being the area of that front piece, I keep spelling front wrong, multiplied by the length, which is 10. And that's going to give us a volume of 4 centimeters squared multiplied by 10 centimeters. And this one's quite nice because 4 times 10 is just going to be 40, and the units will be centimeters cubed. So that gives us a way to find the volume of any type of prism. The cylinder will be the same, but like I said, I'll make another video for that. So yeah, find the area of that front or back shape or top and bottom shape and multiply it by that middle dimension, that length or that height. And you can think of it as that area of the top piece filling up the rest of the shape, and that being the volume. So that's how you find the volume of prism-like objects. So that's another Lil Wickens video, and I'll see you later.